Good morning, good afternoon, or good evening. This is Mr. P here, talking to you about Section 13.2, conjugates of complex numbers. Perhaps you remember these. Hey, if you ever picked a lesson to do before you were on your way to a party, and you were like, you know what, I'm going to do one more of those lessons with that awesome guy, Mr. P. Number one, that was so nice of you. Thank you for calling me awesome. But number two, I think you picked the right one because I'm going to try to get you out of here in 10 minutes. The conjugate of a complex number, remember, a plus bi has a conjugate, a minus bi. The conjugate of a complex number is represented by a plus bi with a bar over it. It's representing complex numbers and their conjugates on a complex plane. So let's go ahead and make a coordinate plane for ourselves here. And we're going to put let's see here. So we got 3 plus I, and the conjugate of 3 plus I is 3 minus I. Remember, the whole purpose of conjugates is that if we multiply them together, we get something that is real. So let's see, 3 plus I is this one. 3 plus I. And then 3 minus I is right here. Yay! So look kind of fun like that. Find the sum of 3 plus I and its conjugate geometrically on the complex plane. So that is 3 plus I plus 3 minus I. And we're going to do that with our geometrically. So I know what some of you are thinking. You already know what it is. How wonderful for you. But first, let's go ahead and get this on here. So I'm going to go there. This 1, 2, 3, 4, 5, 6. 2, 1, 2. Something like that will do. And so let's do 3 plus I. 3 plus I is over 3, up 1. I don't want that particular head there. I want this one. 1, 2, 3 plus I. And we're going to add, so put it tip to tail, 3 minus I, which goes there. Which notice lands on 6, which makes sense. 3 plus 3 is 6. I plus a negative I is 0 I. 6 is 6. 6. Find the modulus of 3 plus I and its conjugate. How are they related? Well, the modulus of 3 plus I is equal to the square root of 3 squared plus 1 squared. Why? Because you would find it by saying m squared equals 3 squared plus 1 squared if this was a right triangle, right? Up 1, right 3, blah, blah, blah. You mind if I do that? You do? I'm sorry, we're doing it. Which is the square root of 9 plus 1, which is the square root of 10. Perhaps you can already see that what is about to happen here, but 3 minus I is going to be equal to the square root of 3 squared plus negative 1 squared. But 3 squared is still 9. The square root, the negative 1 squared is positive 1, which is the square root of 10, which means 3 plus I and the conjugate of 3 plus I, I'm going to go ahead and use those because I never get to, have the same modulus. The square root of 10, which is approximately 3.162. What is the modulus of the conjugate of 4 plus 4i? Well, theoretically, it should be the same as 4 plus 4i, the conjugate of 4 plus 4i, but you know what? We'll just go ahead and go straight. That's going to be the square root of the real part squared plus the imaginary part squared. Because that's all part of a right triangle, you can imagine it 4 plus 4i, right angle, 4, 4. And that's going to be the square root of 16 plus 16, which is the square root of 32, which I can actually reduce. Look how fast I can reduce this. That's going to be the square root of 16 times 2, which is the square root of 16 times the square root of 2, which is 4 square roots of 2. So the modulus of the conjugate of 4 plus 4i is equal to 4 square roots of 2, which, if you approximate the square root of 32, is about 5.657. Put a little box around it, and also a box around this thing I set up here. Okay. Dividing complex numbers. Rationalize the denominator so that the divisor is a real number, and then we can divide the normal way. So we're going to multiply this by a fraction of the complex conjugate, 2 plus 2i over 2 plus 2i. This is really what is 4 divided by 2 minus 2i? Let's find out. The 4 distributes in, giving me 8 plus 8i in the numerator over 2 times 2. Well, I'm just going to do this to the side here. 2 times 2 is 4. 2 times plus 2i is a plus 4i. Negative 2i times 2 is a minus 4i. That's the point. Negative 2i times 2i is a minus 4, because 2 times 2 is 4, I squared. Those eliminate. 4 minus, well, I squared is negative 1. 4 times negative 1 is negative 4. Subtracting negative 4 is the same as adding. So 4 plus 4 is 8. And now I can split this up along the numerator. So 8 over 8 plus 8i over 8, which is 1 plus I. That's how we divide complex numbers. So again, we're going to multiply by the complex conjugate. 2 plus 2i. 2, oopsie, that's not correct. That was the last one. 2 minus I, the complex conjugate of the denominator, which 2 plus I would have a conjugate of 2 minus I. Multiply. Negative 3 times 2 is negative 6. Negative 3 times minus 2i is a plus 3i. 2i times 2 positive 2 is a plus 4i. 2i times a negative I is a minus 2i squared. All over 2 times 2 is 4, minus 2i plus 2i minus I squared. Now, when you see I squared, basically we can get rid of it and change the sign here, because it turns that minus 2 into a minus negative 2, which turns it into a positive. So we can get rid of those and turn that into a plus 1. Because if you're subtracting I squared, you're subtracting a negative 1, which is adding 1. Negative 6 plus 2 is negative 4. 3i plus 4i is 7i. Over, these two are gone, 4. Let's split it up again. Negative 4 over 4 plus 7i over 4, which equals negative 1 plus 7/4 I, or if you prefer, negative 1 plus 4, 1.75 I. And that's how we can divide complex numbers, is by taking their complex conjugates and then just doing the division to each term, which there should just be 2 if it's a simplified complex number. There it is, folks. I believe we got you in under 10 minutes. If you have any questions, do ask your instructor. That's all I've got for you here. This is Mr. P signing off, and hope you have a wonderful rest of your day.